We're going to take a look at reviewing transformation rules and quadratic functions. So we've got this function here, and we're going to just answer some questions about it. So domain, if you look, this graph is extending in both directions forever, and it's also extending up and down forever. So both domain and range would be all real numbers. Let's see, x-intercepts. Looks like I have two. I've got -3, 0, and I've got 5, 0. And then for a y-intercept, it looks like 0, 90. Is the graph increasing or decreasing from 0 to 2? That's this section of the graph, so it appears to be increasing. As I go from left to right, the graph is going up. The coordinate of the local minimum, that would be right here. So where is there a base, right? But the ultimate minimum goes down to -infinity. So that would be at -3, 0. What is the maximum y value? Looks like it's going to go up forever. So positive infinity would be the maximum y value. All right, quick review of these parent functions. Absolute value, and you can think of it as I'm going to plug in right around the origin. Plug in -2, plug in -1, plug in 0, plug in 1, and plug in 2. This has a vertex at 0, 0, and the absolute value is always the positive value of that number. So this is a V-shaped graph with slope of 1 and -1 from the origin. It has a domain of all real numbers, and its range is that y has to be greater than or equal to 0. This is a square root function. So can I take the square root of a negative number? No, I can't. Can I take the square root of 0? Yes, I can. 0, 0. Square root of 1 is 1. Square root of 2 is a decimal. Square root of 3 is a decimal, but the square root of 4 is 2. So it's kind of a sideways half of a parabola. Its domain, we just said, cannot be negative. So x has to be greater than or equal to 0. Its range will also never be negative, so y also has to be greater than or equal to 0. The parent linear graph has a slope of 1 and a y-intercept of 0. Slope of 1, y-intercept of 0. Both domain and range are all real numbers for a linear graph. The cubic function, so if you cube 0, you have 0. If you cube 1, you have 1. If you cubed 2, 2 cubed is 8, which doesn't quite fit on our graph. If you cube -1, -1 cubed is -1, -2 cubed is -8. So it's this kind of S curve through the origin. Its domain and range are also all real numbers. I can go forever in either direction. Okay, so a quick review of our transformation rules. Where has this function been moved? It's been moved right 3 and down 2. To move to the right, that would be a shift of x minus 3 inside the absolute value. To move down, that's a shift of -2 outside the absolute value. This has a slope of 2, so I need to indicate that with a stretch factor of 2 in front of the absolute value. So I would pause the video and try these graphs now on your own, and then see if you get them correct. Now I'm going to say the answers. This has been shifted right 2, and that's it. Still a slope of 1. So just right 2 would be x minus 2 inside the absolute value. This one has been shifted right 1 and down 1, 2, 3, 4, and it has a steepness of 2. So right 1, well, steepness of 2, right 1 and down 1, 2, 3, 4. And this one has been shifted right 1, up 3, and flipped upside down. There's my flip upside down in front of the function, right 1 and up 3. If it was left, it would have been a plus sign inside the parentheses. Parent function of a quadratic, 0, 0, 1 squared is 1, 2 squared is 1, 2, 3, 4, and 3 squared is 9. So if you had to go all the way up, you'd have to go 3, 9. So with the parent function in mind, this is vertex form, right 3, up 1. So I'm just going to shift this graph, right 3, up 1, and then redraw the parabola. Over 1, up 1, over 2, up 1, 2, 3, 4. So it's that same exact parent function, just shifted right 3 and up 1 unit. Standard form is different. So in standard form, you have to remember the formula negative b divided by 2a. So negative 4 is b, negative b. 2a, 2 times negative 2 is also negative 4. Negative 4 divided by 4, positive 1 is the x value of my vertex. Plug 1 back in for all these x's. You'd get negative 2, because negative 2 times 1, plus 4, plus 3. 7 minus 2 is 5. 1, 1, 2, 3, 4, 5. There's my vertex. I'm being flipped over and stretched by a factor of 2. So I'm going to go over 1 and down 2 this time. And instead of 4, I'm going to go over 2 and down 8. 1, 2, 3, 4, 5, 6, 7, 8. So stretching those y values steeper times 2 and flipping it upside down. Number 7 is in intercept form. So I'm going to plot negative 4, 1, 2, 3, 4, and positive 2. Halfway in between is my axis of symmetry where my vertex is going to go. So negative 1 comma something, I'm going to plug negative 1 back in up here to see what I get. 1/3. Negative 1 plus 4 would be 3. And negative 1 minus 2 is negative 3. 1/3 of negative 9 is negative 3. 1, 2, 3. So there's my parabola. If I want to do the steepness here, over 1 up 1/3. Gosh, over 2 normally goes up 4. That one's going to be kind of a horrible point to plot. Let's just plot that. All right, graphing the data in a scatter plot. So to remind you where that is under Stat, Edit, clear out what's in there. I have 2, 0, 4.2, 5, negative 2.8, negative 2, and 6 as my x values. Then negative 2.5, 6, 6, 15, 46, 31, and 35 as my y values. So that's under Stat, Edit. Then you're going to go to Second Stat Plot and turn it on so that you can see your scatter plot. So hit Enter, Enter for on. Then you're going to hit Zoom 9 for Stat. And you're going to look at your dots. There must be another function in my y equals menu, so get out of that. Y equals menu. Oops. Clear what's in there. So that looks like a quadratic function to me. Complete a regression. That's under Stat, Calculate. Stat, Calculate. I want to do a quadratic regression. And I'm going to store it by hitting vars, y bars, function y1, calculate. It just put that equation in my y equals menu. And so my regression would be y equals 2.2x squared minus 8.65x plus 4.93 if I rounded it. Use your regression equation to determine the function when x equals 1. Go to your table. Second table setup, jump to 1 and go second table. The value is negative 1.508 based on my regression equation. And the last question before your guided practice A microphone company's profit is represented by this equation. Y is profit and X is cost. So this is just going to be plugging them in, what price to maximize profit. So I would put this into your Y equals menu. You might want to turn off your plot this time. So I'm putting in the equation 30x minus x squared. And I'm going to hit zoom 6 and see if I can see it, but might not be able to see it yet. Too steep. So I'm going to change my window. I'm going to go x max of 50 and I don't know, y max of, I don't know how steep this is, 1,000. See if I can see it. So now I can see my parabola. They want to know what is f of 10 and f of 30. So go to your table. Go to 10, count by tens. Table. At 10, you make $200. At 30, you make $0. So somewhere in there is going to be our sweet spot. What price should they sell the microphones for? So go back to your graph and find the maximum. Second, calculate maximum. Go to the left of your peak and hit enter. Go to the right of your peak and hit enter twice. Maximum is at $15. They make $225. I hope that's in thousands of dollars for this company to stay in business. I hope that helped. Good luck on the guided practice.